There's something about the endless blackness of space that sends a shiver down your spine, not just because it's cold and empty, but because it's alive with horrors we can barely comprehend. Imagine floating in the void, surrounded by darkness so complete it feels like a living thing, and then realizing you're not alone. Out there, in the infinite expanse, lurk phenomena so terrifying they defy logic, so bizarre they twist the very fabric of reality. The universe isn't just vast, it's hungry, and today we're diving into the top 25 scariest things in deep space. Think you know fear? Wait until you meet the cosmic monsters that make your darkest nightmares seem quaint. Black holes that swallow light itself, rogue planets drifting through the cold like ghost ships, stars that scream in frequencies beyond human hearing. These aren't just science fiction. They're real, they're out there, and they're waiting. Some of them are so destructive, so utterly alien, that if you stumbled upon them, you wouldn't just die, you'd unravel. But here's the thing, the scariest part isn't just what's lurking in the shadows. It's how little we actually know. Every time we point our telescopes into the abyss, the universe whispers back with new terrors, new mysteries that refuse to be solved. And that's what makes this journey so thrilling, because we're not just exploring space, we're staring into the unknown, and who knows what might stare back. So buckle up, by the time we're done, you'll never look at the night sky the same way again. Rogue black holes are the ultimate silent hunters of the cosmos, invisible, unstoppable, and utterly deadly. Unlike their stationary cousins at the centers of galaxies, these loners drift through the void untethered, invisible to the naked eye, yet with gravitational claws strong enough to shred stars. Picture this, a black hole millions of times heavier than our sun, barreling through the Milky Way like a cosmic wrecking ball, warping space around it so fiercely that not even light can escape. And the scariest part, we might not see it coming until it's too late. These wandering nightmares usually form in chaos, either from violent galactic collisions that fling them into the abyss, or the collapse of ancient, massive stars that leave behind a void hungry for more. Detecting them is nearly impossible unless they're actively feeding, pulling gas and dust into their grasp, or bending the light of stars behind them like a funhouse mirror. Scientists call this gravitational lensing, but don't let the calm terminology fool you. It's the universe's way of marking a predator's path. Now imagine one drifting toward our cosmic neighborhood. A rogue black hole wouldn't need to hit us to wreak havoc. Its gravity alone could fling planets out of orbit, distort the solar system's delicate balance, or hurl comets and asteroids toward Earth like bullets. And here's the truly chilling thought. Some researchers believe there could be thousands of these dark wanderers in our galaxy right now, far more than we've ever spotted. The next time you gaze up at the stars, remember, the greatest danger might not be what you see, but what you can't. If rogue black holes are the silent hunters of the cosmos, gamma-ray bursts are the universe's flashbangs, violent, unpredictable, and capable of erasing life in an instant. These are not your average cosmic explosions. A single gamma-ray burst releases more energy in seconds than our sun will in its entire 10 billion-year lifetime. They're so powerful that if one happened within a few thousand light-years of Earth, it would scorch our atmosphere, trigger mass extinctions, and leave our planet barren in the blink of an eye. Most GRBs come in two terrifying flavors. The first are the long bursts lasting from seconds to minutes, born from the collapse of massive stars into black holes. When these stars die, they don't just fade away. They unleash twin jets of radiation at nearly the speed of light, straight through the heart of whatever solar system was unlucky enough to host them. The second type, short bursts, are even more sinister. These are the aftermath of neutron stars colliding, merging in a split-second frenzy that sends shockwaves of gamma radiation tearing across the galaxy. And here's what keeps astronomers awake at night. We've already seen these monsters in action. In 2008, a burst named GRB 080319b lit up halfway across the universe, but if it had happened within our own galaxy, even thousands of light years away, it would have bathed Earth in enough radiation to trigger a global catastrophe. The ozone layer would vanish, exposing all life to deadly ultraviolet rays. Skies would ignite in atmospheric fires, and the delicate balance of our ecosystem would collapse. The chilling truth: we'd have no warning. Gamma-ray bursts travel at the speed of light, meaning the first sign of disaster would be the disaster itself. By the time our satellites detected the burst, it would already be too late. Thankfully, the odds are slim, but not zero. Astronomers estimate that a nearby GRB could sterilize Earth once every few 100 million years, and some theories suggest one might have contributed to the Ordovician extinction 450 million years ago. So while we gaze at the night sky, mesmerized by its beauty, remember, the universe doesn't just create, it destroys, and sometimes it does so with a flash so bright it could rewrite the story of life itself. The Great Attractor lurks in the cosmic shadows like a phantom force, an invisible hand tugging entire galaxies toward it with irresistible gravity. Hidden behind the dense stars and dust of our own Milky Way, this enigmatic region exerts a pull so powerful it distorts the motion of hundreds of thousands of galaxies, including ours. Imagine the universe as a river, and every galaxy within 500 million light-years is caught in its current, drifting helplessly towards something. But what? Scientists first noticed this cosmic tug-of-war in the 1970s, when they mapped the strange, uniform drift of galaxies toward the constellation Centaurus. The math didn't add up. The visible mass in that direction couldn't explain the gravitational pull, meaning whatever was doing the pulling was either hidden or something entirely new. Some theories suggest it could be a supercluster of galaxies so massive it bends space-time itself, while others speculate about exotic dark matter structures or even a gargantuan black hole unlike anything we've seen. But the real spine-chilling twist: we can't see it. The Milky Way's galactic plane blocks our view, shrouding the Great Attractor in a cosmic blind spot. It's like sensing a presence in a pitch-black room, hearing its breath, feeling its pull, but never seeing its face. Advanced X-ray and infrared telescopes have peeled back some of the veil, revealing a dense knot of galaxies nicknamed the Norma Cluster at the heart of the mystery. Yet even that may just be a waypoint, a signpost on the path to something far larger and more terrifying lurking beyond. And here's what unsettles astronomers most: this isn't just a distant curiosity. Our local group of galaxies, including Andromeda and the Milky Way, are all part of this inexorable flow. We're caught in the current, moving at over 600 kilometers per second toward the unknown. Will we find a colossal structure rewriting the laws of physics, a void where gravity itself behaves differently, or something beyond our current understanding? The Great Attractor doesn't just defy explanation, it reminds us how much of the universe remains a whispered question in the dark. Vacuum decay sounds like science fiction, but it might be the most terrifying what if in all of physics. A cosmic doomsday so absolute it wouldn't just destroy Earth, but rewrite the fundamental laws of the universe. Picture reality as a fragile soap bubble floating in a sea of nothingness. Right now, we exist in what scientists call a false vacuum, a seemingly stable state where particles and forces behave predictably. But lurking beneath this stability could be a true vacuum, a lower energy state where the rules of physics as we know them cease to exist. And if a tiny quantum fluctuation triggered a switch to this true vacuum, it would unleash an expanding sphere of annihilation, racing outward at light speed, rewriting existence itself. Here's how it works. Quantum fields dictate everything in the universe, from gravity to light. These fields exist in particular energy states, like marbles resting in the dips of a wobbly tray. Our universe's tray might not be perfectly level. There could be a deeper, more stable valley it hasn't settled into yet. If a random quantum event nudged a tiny region of space into that lower state, it would create a bubble of true vacuum. The laws inside that bubble would be alien. Atoms might not hold together, light could behave differently, and matter as we know it would dissolve. Worse, the bubble's walls would expand uncontrollably, consuming everything in their path. One moment you're sipping coffee on Earth, the next the entire solar system is erased from physics itself. The most chilling part, we wouldn't see it coming. The bubble could form anywhere, anytime, even right next to us, and by the time it reached our planet, destruction would be instant. No warning, no time to react. Even if it started in the farthest galaxy, the end would still be inevitable, creeping toward us at the speed of light. Some physicists argue this might have already happened elsewhere in the cosmos, wiping out distant civilizations without a trace. Thankfully, the odds are vanishingly small. The universe has lasted 13.8 billion years without crumbling into a true vacuum, suggesting our false vacuum state is incredibly stable. But the possibility remains, lurking in equations and haunting the edges of theoretical models. Vacuum decay isn't just death, it's uncreation, a reminder that the universe might be far more fragile than it appears. And that's what makes it so unnerving. The rules we rely on, the constants we take for granted, could all be temporary, waiting for a single quantum sneeze to bring the cosmic house of cards crashing down. Most stars die quietly, fading into cosmic obscurity, but white dwarfs refuse to go gently. These stellar corpses, once like our Sun, have burned through their fuel and collapsed into dense, Earth-sized embers, slowly cooling over billions of years. Yet some of these dead stars have a horrifying secret. They're not dead at all, they're waiting. And when they finally wake up, the result is one of the most violent explosions in the universe, a supernova so bright it outshines entire galaxies. White dwarfs become ticking time bombs when they have a companion star. Slowly, mercilessly, they siphon gas from their neighbor, growing heavier and hotter until they cross a catastrophic threshold, the Chandrasekhar limit. At this point, the pressure inside them triggers runaway nuclear fusion, detonating like a cosmic grenade. But here's the twist: unlike regular supernova, which leave behind neutron stars or black holes, these explosions obliterate the white dwarf completely. No remnant, no warning, just a flash of annihilation so intense it can be seen halfway across the observable universe. What makes zombie stars truly terrifying is their unpredictability. They lurk invisibly in the darkness, indistinguishable from ordinary white dwarfs until suddenly they're not. Astronomers call them type Ia supernova, but the clinical name masks their true nature. They're celestial sleeper agents hiding in plain sight. And because they all explode with nearly identical brightness, scientists use them as standard candles to measure cosmic distances. That means every time we detect one, we're literally seeing the aftermath of a stellar resurrection, a corpse that blew itself apart to light our way through the void. Now imagine one of these detonating close to Earth. A type Ia supernova within 100 light-years would bathe our planet in enough radiation to strip the ozone layer for centuries, triggering mass extinctions and climate collapse. In 2006, astronomers spotted a white dwarf in the T-Pyxides system, just 3,200 light-years away, busily gorging itself on a companion star. If it goes critical, the blast could shine as bright as the full moon for weeks. We'd survive, but the sky would never look the same again, the chilling truth. There are likely thousands of these dormant monsters in our galactic backyard, quietly feeding, biding their time. White dwarfs remind us that in space, even death isn't permanent, and sometimes it's just a prelude to something far more destructive. Dark matter is the universe's silent puppeteer, an invisible hand bending galaxies to its will, dictating the fate of everything we see, yet refusing to reveal itself. It doesn't glow, reflect, or absorb light. It doesn't interact with ordinary matter in any way we can detect, and yet, without it, the cosmos as we know it would fly apart. This ghostly substance makes up roughly 85% of all matter in existence, an unsettling truth that means everything we've ever touched, seen, or loved is just a fraction of reality. The rest is something else. We first glimpsed its shadow in the 1930s when astronomer Fritz Zwicky noticed galaxies in the Coma cluster were moving too fast, so fast that their visible mass couldn't possibly hold them together. There had to be something more, something unseen, binding them with gravitational chains. Decades later, Vera Rubin's observations of spinning galaxies confirmed it. Stars at the edges orbited just as quickly as those near the center, defying Newton's laws. The only explanation, an enormous halo of dark matter enveloping each galaxy, its gravity gripping stars like an invisible fist. But what is it? Theories range from the plausible to the haunting. Weakly interacting massive particles, or WIMP, are a leading candidate. Hypothetical subatomic particles that barely touch ordinary matter, streaming through you right now by the billions without a trace. Actions are another possibility, ghostly particles so light they behave more like waves than matter. Then there's the spine-tingling alternative. Dark matter might not be particles at all, but primordial black holes left over from the Big Bang lurking unseen in the void. The eerie part, we've built entire laboratories miles underground, shielded from cosmic noise, just to catch a whisper of dark matter's presence. So far, nothing. It's like trying to grasp smoke with bare hands. The harder we reach, the more it slips away. Even our most powerful particle colliders, smashing atoms at nearly light speed, haven't forced it to show itself. Every failed experiment deepens the mystery, leaving us with a chilling realization. The universe is built on foundations we don't understand, and here's what unsettles scientists most: dark matter isn't just there. It's shaping us. Simulations show that without its gravitational scaffolding, galaxies like the Milky Way would never have formed. Stars, planets, life itself might owe their existence to this unseen force. Yet for all its cosmic importance, it remains a riddle wrapped in darkness, a reminder that the universe is far stranger than we dare imagine. The next time you look up at the night sky, remember, what you see is just the surface. The real story is written in the shadows. The universe should be teeming with life, with hundreds of billions of galaxies, each with countless stars and even more planets. The math says civilizations ought to be everywhere, buzzing, building, broadcasting. And yet, silence. This eerie contradiction is the Fermi paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" The emptiness isn't just puzzling, it's haunting. Because if life is so rare or so fleeting that even after billions of years the cosmos remains still, what does that mean for us? One of the darkest answers is the Great Filter, a hypothetical barrier that prevents life from reaching interstellar scales. Think of it as a cosmic obstacle course with a single, nearly insurmountable challenge lurking somewhere along the path. If the filter is behind us, something like the improbable jump from chemistry to biology, then we're among the lucky few who made it. But if it's ahead, a catastrophe like self-destructive technology or an inevitable gamma-ray burst, then every civilization hits a wall, and the silence makes perfect, terrifying sense. Other theories paint an even bleaker picture. Maybe advanced civilizations inevitably create artificial intelligence that replaces them, leaving a galaxy full of dead machines. Or perhaps spacefaring species rapidly exhaust their resources and collapse, vanishing before they can spread. Some suggest that the universe is a deliberate quiet zone, that something or someone enforces a rule of silence to avoid attracting attention. Imagine predators lurking in the dark, waiting for the careless to signal their location. Then there's the loneliest possibility of all: we're first. If life needs rare, precise conditions to arise, Earth might be among the earliest planets where it could happen. The universe spent billions of years too hot, too chaotic, too sterile, only now cooling into habitability. In this scenario, we're not late to the party, we're the only party. The Fermi paradox isn't just a question, it's a mirror. The longer we stare into the void and hear nothing, the clearer the reflection becomes. Intelligence might not be an evolutionary triumph, but a fluke. Or worse, a death sentence. Every silent star system whispers the same warning: either we're alone or we're not, and both answers should scare us equally. The Boötes void isn't just empty space, it's a cosmic desert so vast and barren it defies explanation. Stretching 330 million light-years across, this colossal region holds thousands fewer galaxies than it should, making it one of the eeriest anomalies in the observable universe. If you were to drift through it, you'd encounter darkness so profound that the nearest galaxy might be tens of millions of light-years away, a place where stars are almost myths and the silence is deafening. Astronomers call it the Great Nothing, but that nickname doesn't capture the true horror of what it represents: a gaping hole in the fabric of reality where the rules seem broken. Most cosmic voids are bubbles between the web-like filaments of the universe, but the Boötes void is different. It's too big, too empty. When it was discovered in the 1980s, scientists expected to find at least 10,000 galaxies within its borders. Instead, they counted fewer than 60. That's like searching an area the size of North America and finding a single, isolated house. The void's emptiness suggests something unnatural, as if a cosmic vacuum cleaner had sucked away entire clusters of galaxies, leaving behind a ghost town on an unimaginable scale. So what could carve such a hole in the universe? One theory points to dark energy, the mysterious force accelerating the expansion of space. If dark energy behaved differently in the past, it might have pushed matter apart so aggressively that it left behind a void of this magnitude. Another, more unsettling idea involves colliding universes, bubbles of space-time from beyond our own cosmic horizon, crashing together and erasing everything in their path. Or perhaps the void isn't empty at all. Some speculate it could be packed with dark matter so dense it blocks light entirely, or even a graveyard of ancient black holes, their combined gravity warping the space around them into an inescapable pit. Then there's the most chilling possibility. The Boötes void might be evidence of something else entirely, a phenomenon we haven't even named yet. Astronomers have found strange, faint radio signals emanating from its depths, whispers of unknown activity where nothing should exist. Could it be the footprint of an alien megastructure, or the scars of a long-dead civilization's experiment gone wrong? The truth is, every explanation feels like grasping at shadows. What makes the void truly terrifying isn't just its emptiness, it's the reminder that our universe is still full of secrets. We map the cosmos, confident in our understanding, only to stumble across a chasm where the rules don't apply. The Boötes void is a cosmic wake-up call. No matter how much we learn, there will always be darkness beyond the light, and in that darkness, who knows what might be waiting. Neutron-star collisions are the universe's ultimate smackdown, cosmic wrecking balls crashing together with such force that they warp space-time itself. These aren't just any stars. Neutron stars are the collapsed cores of dead suns, so dense that a single teaspoon of their material weighs 1 billion tons. Packed tighter than atoms in a black hole's grin, they spin at dizzying speeds, trailing magnetic fields strong enough to strip electrons from your body light years away. And when two of these monsters spiral toward each other, locked in a death spiral by gravity, the result is pure devastation. The first sign of catastrophe is gravitational waves, ripples in the fabric of reality that stretch and squeeze everything in their path. When scientists detected GW 170817 in 2017, the signal wasn't just a scientific milestone, it was a front-row seat to annihilation. As the stars drew closer, orbiting each other hundreds of times per second, they shredded the very space around them, hurling out energy equivalent to hundreds of millions of supernovae. Then came the collision. In less than a heartbeat, the two neutron stars merged, triggering a kilonova, a detonation so powerful it forged gold in its wake. That's right, the wedding ring on your finger, the gold in your phone. It was likely born in the heart of a cataclysm like this, but don't let the glitter fool you. A kilonova's beauty is lethal. The explosion blasts out jets of radiation at nearly light speed, along with a shockwave of high-energy particles called cosmic rays. If one occurred within a few thousand light-years of Earth, those jets would bathe our planet in enough gamma radiation to trigger mass extinctions, and the debris, a swirling cloud of radioactive heavy metals like uranium and plutonium, raining down on any nearby worlds. It's the universe's version of a dirty bomb, spectacular but deadly. The worst part, we'd have no time to react. From the moment gravitational waves reach us to the arrival of the killing radiation, the delay might be mere minutes. By the time our instruments screamed a warning, the sky would already be burning. Thankfully, close encounters are rare, but neutron stars are everywhere in the Milky Way, lonely, hyperdense ghosts drifting through the dark. And when they finally meet, their embrace isn't just a reunion, it's an apocalypse wrapped in starlight. The universe is expanding, galaxies flying apart at ever-increasing speeds, but what if it's all just the prelude to a cosmic about-face? Meet the Big Crunch, the nightmare scenario where the entire cosmos stops stretching and starts collapsing, pulling every star, planet, and atom back into a singularity so dense it rewrites existence itself. Picture this, trillions of years from now, gravity finally wins. Galaxies reverse course, barreling toward each other in a slow-motion car crash of cosmic proportions. Space itself shrinks, temperatures soar, and the sky burns hotter as the universe crumples like a dying star. The final moments, a superheated oblivion where time, space, and physics cease to have meaning. This isn't just poetic doom, it's a real possibility tied to the universe's ultimate fate. For decades, scientists debated whether gravity might one day overpower dark energy, the mysterious force driving expansion. If there's enough mass in the cosmos, especially if dark matter is more abundant than we think, the Big Crunch becomes inevitable. But here's the chilling twist: a collapsing universe might not be the end. Some theories suggest the singularity could trigger another Big Bang, birthing a brand new cosmos in an endless cycle of death and rebirth. Sounds almost hopeful, right? Think again. A cyclical universe is far from comforting. Each iteration would likely erase all traces of the past, no galaxies reforming the same way, no planets realigning, no life reborn. Everything we know, every achievement, every memory, gone forever, replaced by a universe with entirely new rules. Even scarier, some models suggest these cycles might decay over time, each new universe lasting shorter than the last, until reality flickers out in a final, silent implosion. But the Big Crunch isn't the only cosmic apocalypse on the table. Its polar opposite, the Big Freeze, paints a bleaker, slower end. In this scenario, dark energy keeps accelerating expansion indefinitely, stretching space until galaxies vanish over the horizon, stars burn out, and matter itself decays into cold, subatomic dust. The universe doesn't scream, it whimpers, fading into endless blackness where not even light escapes. The terror of these twin fates isn't just their inevitability, it's their indifference. Whether the universe collapses in fire or fades in ice, the result is the same. Everything we are, everything we've built, reduced to cosmic static, and that's the real horror. The cosmos doesn't hate us, it doesn't even notice us, it just ends. On August 15, 1977, a radio telescope in Ohio picked up a signal so extraordinary that the astronomer who discovered it scrawled, "Wow." In the margin of the printout, a single word that would echo through history. For 72 seconds, a burst of radio waves blared from the constellation Sagittarius at a frequency scientists had long suspected aliens might use, 1420 MHz, the vibration frequency of hydrogen, the most common element in the universe. The signal was 30 times louder than the background noise of space, narrowband like a deliberate transmission, and then just as suddenly as it appeared, it vanished. 47 years later, we still don't know what caused it. The WOW signal checks every box for an artificial broadcast. It wasn't a repeating pulse like a pulsar or a chaotic burst like a quasar. It wasn't a satellite or earthly interference. Those would show up across multiple telescope channels, but this signal appeared in one. It matched the predicted profile of an interstellar beacon so perfectly that researchers spent decades scouring the same patch of sky, hoping for a repeat. They heard nothing, not a whisper. The silence since has been deafening. So what was it? Some cling to the hope of extraterrestrial intelligence, a fleeting hello from a civilization that flickered out or moved on. Others suggest exotic natural phenomena, a comet's hydrogen cloud briefly magnifying a distant star's radio emissions, or a rogue black hole lensing a signal from across the cosmos. There's even a fringe theory that it was a human-made signal reflected off space debris, though no known source fits, but the most unsettling possibility. It was exactly what it seemed, a message, one we missed. The WOW signal haunts SETI researchers because it's the closest we've ever come to proof we're not alone, and it slipped through our fingers. Imagine calling out in a darkened forest and hearing a single, clear reply, then nothing. No footsteps, no rustling leaves, just silence thick enough to choke on. That's the weight of that 72-second broadcast. It's not just a mystery, it's a mirror. However you interpret it, the WOW signal forces us to confront a chilling truth. The universe might be shouting, and we're only listening in fits and starts. And if it was them, what does it mean that they haven't spoken again? Were they silenced? Did they lose interest? Or are they still out there waiting for us to answer? The WOW signal isn't just a relic. It's a question without an answer, burning silently in the void. And that's why, decades later, it still keeps astronomers awake at night. Galactic cannibalism sounds like something out of a cosmic horror story, but it's a brutal reality of how the universe works. Bigger galaxies devouring smaller ones in a slow, inevitable feast. Andromeda, our nearest galactic neighbor, is a prime example of this celestial predation. Over billions of years, it has torn apart and absorbed dozens of dwarf galaxies, stretching their stars into ghostly streams that orbit its core like cosmic breadcrumbs. This isn't some distant phenomenon. It's happening right now, and it's coming for us. Imagine a galaxy like Andromeda, a swirling colossus 2.5 million light-years away, twice the size of the Milky Way. Its gravity a web pulling in everything that dares drift too close. Smaller galaxies don't stand a chance. As they're dragged inward, tidal forces stretch them like taffy, their stars ripped away and scattered into long, shimmering tendrils called tidal streams. These stellar graveyards are all that remain of galaxies that once thrived, now reduced to glittering debris orbiting their killer. Andromeda's halo is littered with them, a testament to its appetite. Now here's where it gets personal. In roughly 4 billion years, the Milky Way and Andromeda will collide in a dance of destruction and rebirth. The two galaxies are hurtling toward each other at 400,000 kilometers per hour, pulled together by gravity's unrelenting grip. When they meet, it won't be a violent crash. Galaxies are mostly empty space, but a slow, mesmerizing tango that reshapes both forever. Stars will be flung into new orbits, gas clouds will collapse into blazing new suns, and the night sky from any surviving planets will become a kaleidoscope of alien constellations. But don't let the beauty fool you. The merger will spell the end of both galaxies as we know them. Simulations show the two spirals tearing each other apart, their delicate structures shredded into a single, elliptical blob astronomers call Andromeda. Stars might survive, but the orderly arms of the Milky Way, the same patterns our ancestors traced into constellations, will vanish forever. And if any civilizations are around to witness it, they'll watch their familiar sky unravel in real time. The chilling part, this isn't just speculation. We've caught Andromeda in the act before. The Gaia spacecraft revealed remnants of a massive galaxy it devoured 10 billion years ago, a ghostly skeleton hidden in its stellar halo. And the Milky Way is no saint either. We've consumed our own dwarf galaxies, like the Sagittarius dwarf spheroidal, whose stars now swirl through our outskirts like cosmic ashes. Galactic cannibalism is the universe's way of reminding us that nothing lasts forever, not even the galaxies we call home. Whether it's Andromeda's hunger or the Milky Way's own predatory past, the message is clear. In the grand, dark ocean of space, you're either the hunter or the prey. And time is running out for one of us. Quasars are the universe's first monsters, supermassive black holes turned up to 11, devouring matter with such ferocity that they outshine entire galaxies. These cosmic flamethrowers, born in the chaos of the early universe, blast out enough energy to sterilize planets light years away, their brilliance visible across billions of years of spacetime. And while most have faded into silence, their lingering echoes tell a story of a time when the cosmos was young, violent, and drenched in radiation. At the heart of every quasar lies a black hole with an appetite beyond comprehension. Unlike the dormant giants at the centers of modern galaxies, these ancient beasts gorged themselves on gas, dust, and even stars, heating the infalling material to millions of degrees until it glowed brighter than a trillion suns. The energy released wasn't just light. It was a deadly barrage of X-rays and gamma rays, jets of plasma shooting outward at near light speed, carving through the infant universe like a blowtorch through fog. What makes quasars truly terrifying is their reach. The brightest, like 3C273, shine with the luminosity of 1,000 Milky Ways, their light taking billions of years to reach us. That means when we observe them today, we're peering back into an era when galaxies were still forming, and space was a battleground of radiation and raw cosmic power. If a quasar ignited anywhere near the Milky Way now, its jets would cook our atmosphere, strip away our ozone layer, and bathe Earth in enough radiation to end complex life in a geological blink. But why were quasars so common in the early universe? The answer lies in the chaos of creation. Back then, galaxies were smaller, gas was plentiful, and black holes had all the fuel they needed to feast unchecked. As the universe expanded and galaxies grew, mergers diluted their cores, starved the central black holes, and eventually silenced the quasars. Today, their descendants, like Sagittarius, a star in our own galaxy, are shadows of their former selves, their fiery adolescence long past. Yet quasars aren't just relics, they shaped everything. Their radiation helped reionize the early universe, tearing apart hydrogen atoms and clearing the cosmic fog that once obscured light. They may have even stunted galaxy growth, their jets pushing away gas that would have formed stars, leaving some galaxies stunted and dark. In a way, we owe our existence to their violence. They helped forge the transparent, structured universe we call home. The next time you look up at a quiet night sky, remember, it wasn't always so calm. Once, the heavens burned with the fury of quasars, and their dying light still whispers to us across the eons. They're proof that even the darkest voids of space were once alive with unimaginable fire. Imagine a single satellite exploding in orbit, shattering into thousands of razor-sharp fragments hurtling at 28,000 kilometers per hour. Now picture those shards slamming into other satellites, disintegrating them into even more debris, a chain reaction spiraling out of control until Earth is wrapped in a swirling storm of metal shrapnel. This isn't science fiction. It's the Kessler syndrome, a nightmare scenario where space becomes so littered with wreckage that launching anything, even a single rocket, could be suicide. The math is terrifyingly simple. At orbital speeds, even a fleck of paint packs the punch of a speeding bullet. A 1-centimeter bolt, that's a grenade with no warning. Every collision creates fresh debris, which increases the odds of more collisions, which creates more debris, until low Earth orbit transforms into a deadly pinball machine. Scientists call this collisional cascading, but the result is more like a cosmic quarantine. a point where every spacecraft we send up would be shredded within hours, cutting humanity off from space indefinitely. We've already seen glimpses of this future. In 2009, a defunct Russian satellite collided with an active American one, spawning over 2,000 trackable fragments, many still orbiting today. 2 years earlier, China's anti-satellite missile test littered space with 3,500 pieces of debris, some reaching altitudes that'll take centuries to decay. Even routine operations leave corpses, dead satellites, discarded rocket stages, even lost astronaut tools drifting like landmines. Right now, over 128 million fragments larger than a millimeter circle Earth, with 36,000 big enough to obliterate a spacecraft on impact. The tipping point could come sooner than we think. Simulations suggest that certain orbits, like the crowded band 800 to 1,000 kilometers up, are already primed for runaway Kessler events. Once the cascade starts, it won't stop. Satellites critical for weather forecasting, GPS, and global communications would vanish first, followed by the International Space Station, either abandoned or punctured. Future moon missions, forget it. Mars colonies trapped on Earth. The debris cloud could linger for millennia, a monument to humanity's carelessness. Yet the greatest tragedy isn't losing access to space. It's the silence. A Kessler-prisoned Earth would hear nothing from orbit, no distress calls, no satellite pings, just static where our technology once hummed. Telescopes would peer out at stars we can no longer reach, while generations born too late would gaze up at a sky glittering with the wreckage of what we threw away. The stars would still be there, but we'd be grounded, and the clock is ticking. Every year, thousands of new satellites flood orbits already stretched thin. Mega constellations like Starlink promise global internet, but add tens of thousands more potential debris sources. Without drastic action, active debris removal, stricter regulations, or even self-destruct protocols for dead satellites, we're flirting with disaster. The Kessler syndrome isn't just a theory, it's a countdown, and once it hits zero, there's no reset button. Somewhere beyond the edge of the known universe, something is pulling. Not just on a few galaxies, but on thousands of them, entire clusters hurtling in the same direction at speeds over 2 million miles per hour toward a place with no light, no visible mass, nothing we can detect. Scientists call this the dark flow, and it's one of the few cosmic mysteries that threatens to upend everything we thought we knew about how the universe works. This isn't just random drift. When researchers first mapped the movement of galaxy clusters in 2008, they expected to see the gentle, uniform expansion of the cosmos. Instead, they found a river of galaxies all flowing the same way, as if caught in some colossal gravitational current. The only explanation, something massive, something beyond our observable universe, is yanking them toward it. And whatever it is, it defies the laws of physics as we understand them. The sheer scale of this anomaly is staggering. The dark flow stretches over billions of light years, far beyond where the Big Bang's afterglow fades into darkness. Normal gravity can't explain it. There's not enough matter in the visible cosmos to create such a pull. Even dark matter, the universe's invisible scaffolding, shouldn't have this kind of reach. So what's left? One theory is as unsettling as it is thrilling. We're feeling the gravity of another universe. In the multiverse model, our cosmos might be one bubble floating in an endless sea of others, each with its own physics, its own laws. If a neighboring universe happened to brush against ours, its mass, however alien, could tug on our galaxies like a magnet. Picture two soap bubbles touching in a sink. Their surfaces would warp where they meet. What if the dark flow is our first glimpse of that warp? Then there's the darker alternative. What if the flow isn't coming from another universe, but from something inside ours? A structure so vast and dense it redefines cosmic scale. Astronomers have found hints of superstructures before, like the Hercules Corona Borealis Great Wall, a filament of galaxies stretching 10 billion light-years. But even that pales next to whatever could cause the dark flow. The scariest part, we might never know for sure. The source of the pull lies beyond our cosmic horizon, the point where space expands faster than light can travel. Any signal from there is lost to us forever, leaving only the ghostly trail of galaxies caught in its wake. It's like standing on a beach, watching the tide rush out, and realizing something impossibly huge is moving beneath the waves, something you'll never see. That's the chilling legacy of the dark flow. It's not just a mystery, it's a reminder that our universe might be stranger than we dare imagine. And out there, in the infinite dark, forces we can't see or comprehend are rewriting the rules of reality itself. Most stars drift peacefully through their galaxies, bound by gravity's gentle embrace, but not hypervelocity stars. These rogue bullets of the cosmos have been flung into the void at speeds over 1,000,000 miles per hour, fast enough to escape their home galaxies forever. Born from violent encounters with supermassive black holes or cataclysmic supernova explosions, they streak through the darkness like unguided missiles, carrying enough energy to reshape entire solar systems. And if one were headed our way, the chaos would be beyond imagination. The journey of a hypervelocity star begins with betrayal. Some are ejected when binary star systems wander too close to a galaxy's central black hole. As one star gets captured, its partner is slingshotted outward at unimaginable speeds, a cosmic game of gravitational pinball where the loser becomes a lone wanderer. Others are spat out by the shockwaves of dying stars, their explosive births kicking them clear of galactic gravity. Once free, they become unstoppable, crossing intergalactic distances in eons, silent and deadly. Now picture one barreling toward the solar system. Even at light years away, its approach would send ripples through the delicate balance of our cosmic neighborhood. The star's gravity would perturb the Oort cloud, that distant shell of icy debris surrounding our system, hurling comets inward like a shotgun blast. Long before the star itself arrived, Earth could face a hailstorm of extinction-level impacts, each comet a potential dinosaur killer. And as the star drew closer, its pull would warp the orbits of planets, potentially flinging Mercury or Venus into the Sun, or worse, nudging Earth into a fatal collision course. The star's light alone would be a herald of doom. Brighter than any other star in the sky, it would grow steadily larger, its glare outshining the moon as it neared. Solar winds from its furious approach would batter our magnetosphere, stripping away the atmosphere over centuries, and if it passed within a few light years, the upheaval would be catastrophic. Neptune and Uranus could be ripped from their orbits entirely, sent tumbling into interstellar space, while the asteroid belt might scatter like shrapnel. Yet the real terror lies in the aftermath. Even if the star didn't collide with the Sun directly, its gravitational wake would leave the solar system permanently scarred. Planetary orbits could become elliptical and unstable, triggering extreme climate swings on Earth as our distance from the Sun fluctuated wildly. The delicate Goldilocks zone we call home might vanish altogether, leaving our world a frozen wasteland or a scorched desert. Here's the twist: this isn't just hypothetical. We've already spotted hypervelocity stars racing through the Milky Way. One, known as S5HVS1, is moving so fast it's on a one-way trip out of our galaxy. Others, like the infamous Lamos HVS2, clock in at over 700 kilometers per second, enough to cross the distance from Earth to the Moon in under 20 minutes. And while none are currently headed our way, the universe is full of surprises. What makes these stellar fugitives so unsettling isn't just their speed, it's their indifference. A hypervelocity star wouldn't strike with malice. It wouldn't even notice us. It would simply pass through, an unstoppable force leaving ruin in its wake, as uncaring as a hurricane. And in the grand silence of space, that might be the most frightening thing of all. Sometimes destruction doesn't come looking for you, it just happens to be passing by. The Black Widow pulsar isn't just a dead star, it's a cosmic vampire, spinning at dizzying speeds while slowly draining the life from its companion. Picture this, a neutron star, no larger than a city but weighing more than our sun, whirling around nearly 700 times every second. Its surface gravity is so intense that a marshmallow dropped onto it would hit with the force of a nuclear bomb. But this stellar corpse isn't content with its own demise. It's dragging another star down with it, blasting it with radiation so fierce it's literally evaporating the poor thing into oblivion. Pulsars like this are the remnants of supernova explosions, the crushed cores of once mighty stars now reduced to hyperdense spheres of neutrons. Most just spin quietly, beaming radio waves like lighthouses in the dark, but the Black Widow, officially known as PSRJ 131-1-3430, takes things to a horrifying extreme. Its rapid rotation generates a magnetic field trillions of times stronger than Earth's, accelerating particles into deadly jets that constantly bombard its neighboring star. Over time, this relentless assault has stripped away nearly 90% of the companion's mass, leaving behind a smoldering husk not much bigger than Jupiter. This isn't just a slow death, it's systematic annihilation. The pulsar's radiation pressure has blown much of the stolen gas into space, creating a vast, glowing nebula of ionized particles that stretches across light years. Meanwhile, the remaining material spirals onto the pulsar's surface, superheating until it emits X-rays bright enough to burn through lead. It's a gruesome spectacle, one star cannibalizing another, turning its partner into little more than cosmic kindling. But the Black Widow's cruelty doesn't stop there. Its gravitational pull has locked the companion star into a death spiral, forcing it to orbit just once every 93 minutes. That's so close the entire system could fit inside our sun with room to spare. The star's outer layers are being torn away at a rate of about 1 Earth mass every 10,000 years, meaning eventually nothing will remain but the pulsar itself, alone once more, searching for its next victim. What makes this system so chilling isn't just its violence, it's the inevitability. The universe operates on brutal rules where even in death the strong consume the weak. The Black Widow pulsar isn't an anomaly, it's a preview. Over billions of years, countless binary stars will meet similar fates, their dances of mutual survival twisted into one-sided slaughter. And when our own sun dies, its corpse might one day drift close enough to another star to begin the cycle anew. So the next time you gaze up at the night sky, remember, behind the beauty lies a cosmos indifferent to mercy. Stars burn, explode, and fade, but some, like the Black Widow, ensure they don't go quietly. They take everything with them, far beyond the orbits of Neptune and Pluto. In the frozen darkness where the sun's light is little more than a faint glimmer, lies a graveyard of ice and rock, the Oort cloud. This vast spherical shell of icy debris stretches nearly a light year from the sun, a relic of the solar system's violent birth. Most of its trillions of frozen bodies drift in perpetual stillness, untouched by time. But hidden among them could be threats we can't yet see: rogue planets cast adrift from other stars, or dormant comets waiting for the slightest gravitational nudge to send them hurtling toward Earth. The Oort cloud is the ultimate cosmic deep freeze, a place so distant and mysterious we've never directly observed it. Its existence is only inferred from the long-period comets that occasionally plunge inward, their elongated orbits tracing back to this remote frontier. These icy wanderers, like the famous Hale-Bopp, spend most of their existence in the cloud's silent depths, only awakening when a passing star's gravity or the Milky Way's tidal forces jostle them loose. Once disturbed, they begin a deadly fall toward the inner solar system, a journey that can take millions of years, ending in a blazing spectacle or a catastrophic impact. But comets aren't the only dangers lurking out there. Some astronomers theorize the Oort cloud could harbor rogue planets, worlds ejected from their home star systems, now drifting through interstellar space. These frozen nomads, sometimes larger than Earth, would be nearly invisible in the darkness, their presence betrayed only by the subtle warping of distant starlight. If one were to stray too close to our solar system, its gravity could trigger a comet storm on a scale never seen in human history. Imagine thousands of Hale-Bopp-sized projectiles hurtling toward us at once, an extinction-level event with no warning. Even more unsettling, we might never see it coming. The Oort cloud is so vast and diffuse that any interloper could slip through undetected until it was too late. In 2014, astronomers discovered a faint object named SETI, which orbits far beyond the Kuiper belt in a strange, elongated path. Some believe SETI's odd trajectory hints at the gravitational pull of an unseen, massive object, perhaps a hidden planet 10 times the size of Earth, lurking in the Oort cloud's shadows. They've nicknamed it Planet 9, and while it remains hypothetical, its possible existence raises a chilling question. What else is out there? The Oort cloud isn't just a relic of our past, it's a loaded gun pointed at our future. Every gravitational ripple from a passing star or rogue planet could send another deadly payload our way. And unlike the asteroid belt where we track most large objects, the Oort cloud remains a blind spot in our cosmic defenses. By the time we spotted an incoming comet from its depths, we might have just years or months to react. So the next time you gaze up at a shooting star, remember, it might be more than just a streak of light. It could be a warning from the frozen dark, a reminder that the universe never truly lets us rest. The Oort cloud holds the remnants of our solar system's birth, and it might just hold the seeds of its end. The sun has burned steadily for 4.6 billion years, a golden constant in Earth's sky, but its stability is an illusion. Like all stars, it's living on borrowed time, and when its final act begins, the consequences will be nothing short of apocalyptic. 5 billion years from now, the hydrogen fuel in its core will finally run dry, triggering a chain reaction that will reshape the solar system in a slow, inevitable catastrophe. First, the sun will swell into a red giant, its outer layers expanding outward like a dying breath. Mercury will vanish first, swallowed whole as the star's bloated surface engulfs it. Venus won't stand a chance either, its thick atmosphere scorched away long before the sun's fiery grasp consumes it completely. Then comes Earth's turn. As the sun grows hundreds of times larger, its heat will intensify, boiling away our oceans in a matter of centuries. The once blue planet will become a cracked wasteland, its surface temperatures soaring to over 1,000 degrees hot enough to melt stone. Mountains will slump like wax, continents will warp, and any remnants of life will be reduced to ash drifting on superheated winds. But the horror doesn't stop there. Even if Earth somehow escapes direct engulfment, a possibility that hinges on the sun losing mass and weakening its gravitational pull, the expanded star's solar winds will strip away what's left of our atmosphere, leaving behind a barren rock orbiting a monstrous crimson orb. The sun's new phase won't last forever, though. After a few 100 million years of expansion, it will shed its outer layers in a shimmering planetary nebula, exposing its collapsing core, a white dwarf no larger than Earth but unimaginably dense. This tiny, blazing ember will glow faintly for trillions of years, a ghostly remnant of the star that once bathed our world in light. By then, the solar system will be unrecognizable. Mars, baked and lifeless, will drift in perpetual twilight. The gas giants, their icy moons melted and evaporated, will orbit a dimming relic. And Earth, if it still exists, will be a cold, airless tomb, its history erased beneath layers of glassy rock forged in the sun's dying fires. What makes this fate so unsettling isn't just its inevitability, it's the sheer indifference of the universe. The sun won't die out of malice, it won't even notice us. It will simply follow the laws of physics, burning until it can't, leaving behind a silent graveyard where planets once thrived. And long before that final act, humanity will have faced an impossible choice: flee to the stars or perish with our cradle. The clock is ticking, we just can't hear it yet. Magnetars are the universe's ultimate electromagnetic nightmares, neutron stars so magnetically charged they twist the very fabric of reality around them. Imagine a stellar corpse no bigger than Manhattan, yet with a magnetic field a quadrillion times stronger than Earth's. That's enough power to rip the electrons off atoms halfway across the galaxy, liquefying anything alive from thousands of light years away. These cosmic monsters don't just bend the rules of physics, they snap them in half. Most neutron stars are already extreme, born from the ashes of supernovae so violent they crush stellar cores into hyperdense spheres of neutrons. But magnetars take that terror to another level. Their magnetic fields are so intense they create starquakes, ruptures in their solid crust that unleash bursts of gamma rays and X-rays with the energy of a solar flare packed into a millisecond. These explosions, aptly named soft gamma repeaters, can light up the entire Milky Way for a heartbeat, outshining every other source of high-energy radiation in the sky. Then there's December 27, 2004, the day a magnetar reminded Earth who's boss. From 50,000 light-years away, in the constellation Sagittarius, SGR 1806-20 erupted in a gamma-ray flare so powerful it briefly compressed our planet's magnetosphere, ionizing the upper atmosphere and disrupting radio communications worldwide. Satellites in low Earth orbit were bombarded with enough radiation to temporarily blind their sensors, as if the cosmos had flicked a switch marked chaos. What makes this event terrifying isn't just its scale, it's the sheer randomness. Magnetars don't announce their tantrums. One moment they're silent, the next they're flaying nearby space with enough radiation to sterilize planets. Had SGR 1806-20 been even a fraction closer, say, within 10 light-years the flare could have stripped Earth's ozone layer, triggering a mass extinction within days. Yet the real horror lies in their longevity. Unlike supernovae, which burn out quickly, magnetars can keep pulsing for thousands of years, their magnetic fields slowly decaying as they torment the cosmos. Some, like the infamous 1E1048.1-5937, even emit eerie radio waves that sound like heartbeats, a chilling reminder that these dead stars are still very much alive with fury. The universe is full of monsters, but magnetars are different. They don't need to consume or collide to wreak havoc. Their mere existence is a threat, their magnetic fields stretching across light years like invisible claws. And sometimes, when we least expect it, they remind us just how fragile our place in the cosmos really is. The universe won't end with fire or ice, but with something far quieter, an endless, irreversible slide into darkness. This is heat death, the ultimate victory of entropy, where every star burns out, every black hole evaporates, and even time itself loses all meaning. Picture a cosmos so cold and empty that the temperature everywhere reaches absolute zero, where not a single particle moves, and the last flicker of energy dissipates into the infinite void. It's not an explosion or a collapse, it's the universe falling asleep forever. The process begins slowly, almost imperceptibly. Over the next trillion years, galaxies will exhaust their gas reserves, star formation will cease, and the night sky will grow darker as suns wink out one by one. The Milky Way, Andromeda, and all their neighbors will merge into a single, fading supergalaxy, its remaining stars huddled together like embers in a dying fire. Eventually, even those embers will cool. Red dwarfs, the longest-lived stars, will finally sputter out after 10 trillion years, leaving behind dim white dwarfs and neutron stars, cosmic tombstones glowing faintly with residual heat. But the true horror comes later. Protons, the building blocks of matter itself, might not last forever. Some theories suggest they'll decay over unimaginable timescales, vanishing into radiation. If that happens, every atom in the universe will gradually unravel. Planets, asteroids, even the corpses of dead stars will dissolve into nothingness, leaving behind only a sea of subatomic particles drifting farther and farther apart. Black holes, the last bastions of structure, will dominate this era, growing larger as they devour the remnants of galaxies, yet even they aren't eternal. Over googles of years, a number so vast it dwarfs every atom in the observable universe, they'll evaporate through Hawking radiation, their final moments marked by feeble bursts of light in an otherwise endless night. By this point, space will have stretched so far that no two particles will ever interact again. The universe will be a static, featureless void, its temperature uniform everywhere. No heat, no motion, no change. Just an infinite expanse of absolute zero, where the very concept of time becomes meaningless because nothing happens. The cosmos will have reached maximum entropy, a state of perfect, unbroken equilibrium where energy is so evenly distributed that no work can ever be done again. No stars will ignite, no life will stir, no thought will flicker. It's the ultimate silence. What makes heat death so unnerving isn't just the scale of time involved, it's the inevitability. Every process we see today, from the fusion of stars to the beating of hearts, is only possible because energy flows from hot to cold. But one day that flow will stop. The universe will be a spent fuel rod, drained of all usable energy, its story written in full. And yet, in the grandest irony, this bleak fate might not be the very end. Some theories suggest quantum fluctuations could birth new universes from the void, sparking new big bangs in the ashes of the old. But for our cosmos, there's no rebirth, only the long, slow fade to black. So when you look up at the stars tonight, remember, their light is fleeting. The universe is burning through its fuel, and one day the fire will go out. Not with a bang, not with a whimper, but with the quietest sigh imaginable, a whisper lost in an ocean of endless dark. In the cold, silent expanse beyond our solar system, two tiny spacecraft defied the laws of physics, and no one knows why. NASA Pioneer 10 and 11, launched in the early 1970s, were humanity's first emissaries to the outer planets and beyond. But as they drifted farther from the sun, scientists noticed something impossible. Both probes were slowing down. Not from friction or solar wind, but as if some unseen hand had reached out and tugged them backward. This tiny, persistent deceleration became known as the Pioneer anomaly, and for decades it haunted physicists like a ghost in the equations. At first, the numbers seemed insignificant, a barely perceptible drag, equivalent to a 10 billionth of Earth's gravity. But over years, that minuscule force added up, pulling the probes off course by hundreds of thousands of miles. Engineers checked everything: fuel leaks, thermal radiation, even the faint pressure of sunlight on the spacecraft. Nothing explained it. The probes behaved as if the universe itself had extra gravity where none should exist, a cosmic, slow-down sign posted in the void. Theories ranged from the mundane to the mind-bending. Maybe heat radiating from the probe's plutonium power sources acted like a tiny thruster in reverse. Or perhaps our understanding of gravity was incomplete at interstellar distances. Some dared to whisper about new physics, hidden dimensions, dark matter's invisible pull, or even modifications to Einstein's theory of general relativity. The most unsettling possibility: the anomaly wasn't a flaw in our models. It was a feature of reality we'd never noticed before. Then, in 2012, the mystery deepened. Meticulous analysis of old data revealed the deceleration wasn't constant. It was decaying over time, as if whatever force acted on the pioneers was slowly losing strength. This bizarre detail ruled out many explanations, leaving scientists even more perplexed. By this point, both probes had fallen silent: Pioneer 10 in 2003, Pioneer 11 in 1995, taking their secrets with them into the dark. Today, the Pioneer anomaly remains unsolved. Newer spacecraft, like the ultra-precise New Horizons, haven't experienced the same drag, suggesting the effect might be unique to the Pioneer's design. Yet that answer feels unsatisfying, like blaming a ghost's footsteps on creaky floorboards. The truth is, deep space might still hold forces we haven't named, quirks of gravity that only reveal themselves when we venture far enough to feel their pull. The Pioneer's journey isn't just a tale of two probes. It's a reminder that even in the void, the universe keeps surprises up its sleeve. Every time we think we've mapped the edges of physics, something tugs at the corner of the page, whispering that there's more to learn. And out there, in the endless night, the Pioneers drift on, carrying their enigma deeper into the unknown. At first glance, the Red Rectangle Nebula shouldn't exist, a cosmic structure so geometrically perfect it looks like it was drafted by celestial architects. Located 2,300 light-years away in the constellation Monoceros, this blood-red trapezoid defies everything we know about how nebulae form. Most stellar death shrouds are chaotic swirls of gas, like the Crab Nebula's tangled filaments or the Helix Nebula's delicate bubbles, but the Red Rectangle. Its sides are nearly straight, its corners sharp, and its entire form aligned with eerie precision. Even stranger, when viewed edge-on, it reveals a ladder-like series of glowing rungs, a structure astronomers have never seen anywhere else in the universe. This isn't just an interstellar oddity, it's a cosmic crime scene. At the nebula's heart lies HD 44179, a dying star locked in a deadly dance with its binary companion. As the primary star sheds its outer layers, the smaller star's gravity sculpts the ejected material into that uncanny rectangular shape, while dust grains scatter blue light and let only red pass through, hence the nebula's eerie crimson glow. But while science can explain the color, the geometry remains borderline inexplicable. Natural processes rarely produce such clean angles, especially not on scales spanning light years. Cue the whispers of alien megastructure. The Red Rectangle's unnatural symmetry has fueled speculation that we might be looking at something far more profound than stellar winds. Perhaps Dyson spheres under construction, or energy harvesters built by civilizations harnessing their dying sun. The ladder-like rungs only deepen the mystery, resembling scaffolding for some unimaginable project. Of course, astrophysicists have more grounded theories, like perfectly aligned jets or shockwaves interacting with circumstellar disks. But even these explanations feel stretched when confronted with the nebula's razor-sharp edges. Then there's the timing. The Red Rectangle is shockingly young by cosmic standards, its central star only beginning its death throes. That means we're catching this phenomenon at a rare, fleeting moment, like walking into a workshop mid-construction. Whether natural or otherwise, the processes shaping it are unfolding right now, giving us a front-row seat to a cosmic event that may vanish within millennia. Most nebulae linger for tens of thousands of years, but this one, its perfection might be ephemeral, destined to dissolve into the chaotic beauty we expect from stellar graveyards. What makes the Red Rectangle truly haunting isn't just its shape, it's the lingering doubt. In a universe where nature seldom draws straight lines, this structure stands as a cryptic challenge to our understanding. Every time we think we've decoded it, another layer of mystery emerges. Perhaps it's a lesson in humility. Even after centuries of stargazing, the cosmos still knows how to hand us a geometry problem we can't quite solve. In the silent vastness of the cosmos, the greatest threat might not be what's out there, but what's listening. The dark forest theory offers one of the most unsettling solutions to the Fermi paradox, painting the universe not as a bustling galactic community, but as a predator-filled wilderness where every civilization learns the same brutal lesson: speak up and you die. Picture a dark forest at night where hunters creep between the trees. Any sound, a snapped twig, a rustling bush, could mean death. So everyone stays perfectly still, barely breathing, praying not to be noticed. Now imagine that forest spans the entire universe, and the hunters wield planet-killing weapons. welcome to the nightmare logic of cosmic survival. This isn't just speculative fiction. The theory, popularized by sci-fi author Liu Cixin, rests on three terrifying assumptions. First, all civilizations prioritize survival above all else. Second, resources are finite eventually, someone will fight over them. And third, there's no way to know if an alien species is hostile until it's too late. Put those together, and the only rational move is to stay hidden. Any signal, any beacon announcing your location might draw something far older, far more advanced, and far less merciful. That's why the universe seems so silent, not because we're alone, but because everyone else is too scared to speak. History offers grim parallels. When European explorers reached new lands, indigenous cultures often suffered devastation, not from malice but from sheer technological disparity. A single ship-borne disease could wipe out civilizations that hadn't built immunity. Now scale that up to a galaxy where some species might be billions of years older. Their weapons could harness supernovae, their surveillance might span star systems, and their motives could be as incomprehensible to us as geopolitics is to ants. In such a cosmos, broadcasting our existence isn't just naive, it's suicidal. Even our own attempts at communication take on a sinister edge under this lens. The Arecibo message beamed toward star cluster M13 in 1974, a reckless shout in the dark, SETI radio telescopes listening for replies. Potentially inviting disaster, some scientists argue we should be doing the opposite, building radio silence protocols, masking Earth's transmissions, even dimming our industrial signatures. Because the longer we go unnoticed, the longer we survive. The darkest twist, the theory might already be playing out. Those mysterious fast radio bursts from deep space, could they be the final screams of civilizations that broke silence? The wow signal might not have been a greeting but a trap, and the great filter, perhaps it's not a natural barrier but something far worse, a galactic culling where the first rule is simple: never let them know you're here. So the next time you gaze at the stars, wondering why they're so quiet, remember silence isn't emptiness. It's the sound of a universe holding its breath. Waiting, watching, and praying the monsters don't hear it first. For over 60 years, we've trained radio telescopes on the stars, listening for whispers in the cosmic static, a hello, a song, even the hum of alien machinery. Yet all SETI ears have heard is silence, an unbroken hush stretching across light years. The great silence isn't just puzzling, it's unnerving. With trillions of planets in the Milky Way alone, the odds say someone should be out there. So where is everyone? The answer might not be a matter of bad luck, it could be a warning. One possibility is grimly simple: we're alone. Life might be rarer than we think, arising only under conditions so precise they border on miraculous. Earth's history is a gauntlet of near misses, asteroid impacts, climate swings, magnetic field fluctuations, any one of which could have snuffed out life before it grew complex. If intelligence is a statistical fluke, a 1 in a quintillion roll of the cosmic dice, then the silence makes sense. The universe isn't ignoring us. It's empty, but there's a darker alternative. What if the silence isn't natural but enforced? Imagine a galaxy where civilizations rise, expand, and inevitably trigger their own destruction, whether through war, environmental collapse, or rogue artificial intelligence. This is the great filter theory's bleakest take. The hurdle isn't behind us like the jump from single cells to intelligence. It's ahead, a cliff every species drives itself over. The quiet sky isn't a mystery, it's an obituary. Then there's the most chilling scenario of all. The universe isn't silent because no one's there, it's silent because they're hiding. The dark forest hypothesis paints the cosmos as a battlefield where civilizations stay quiet to avoid attracting predators. Any signal, a radio broadcast, a probe, even industrial waste heat, could mark a planet for annihilation by something older, smarter, and ruthless. In this version of reality, SETI isn't just futile, it's dangerous. Every time we beam messages into the void, we're essentially shouting into a jungle full of tigers. But here's what keeps astronomers staring at their monitors, ears straining for a signal against the noise. The silence isn't absolute. There are anomalies, the wow signal, those repeating fast radio bursts, the odd behavior of Tabby's star, hints that something might be out there, flickering at the edge of perception. Maybe we're not listening right. Maybe they're speaking in neutrino pulses or quantum entanglements, technologies we're centuries from understanding. Or maybe they're watching us right now, waiting to see if we're worth the risk of a reply. The great silence isn't just a scientific challenge, it's a mirror. How we interpret it says everything about our hopes, our fears, and our place in the cosmos. Are we orphans, survivors, or prey? The universe hasn't answered yet. But the longer the quiet stretches, the louder the question becomes. We've journeyed through the cosmos' darkest corners, from rogue black holes drifting unseen through our galaxy to gamma-ray bursts that could erase life in a blink. We've faced the Great Attractor's unsolved pull, the specter of vacuum decay rewriting reality itself, and zombie stars lurking in the shadows waiting to detonate. We've shuddered at dark matter's invisible grip, wrestled with the Fermi paradox's deafening silence, and gaped at the Boötes void's unnatural emptiness. Neutron star collisions painted the sky with gold forged in apocalypse, while the Big Crunch whispered of a universe collapsing in on itself. The wow signal taunted us with its 72-second mystery. Andromeda's galactic cannibalism warned of our inevitable collision, and quasars revealed the young universe's fiery rage. The Kessler syndrome threatened to cage us on Earth. The dark flow hinted at forces beyond our horizon, and hypervelocity stars raced toward catastrophe. The Black Widow pulsar spun its lethal web, the Oort cloud's icy sentinels loomed in the dark, and our sun's future death sentence hung overhead. Magnetar's cracked spacetime with magnetic fury. Heat death promised an eternal frozen halt, and the Pioneer anomaly teased physics we still can't explain. The red rectangle's unnatural geometry defied reason. The dark forest theory screamed stay silent, and the great silence itself became the most haunting mystery of all. What makes these horrors so chilling isn't just their scale, it's their indifference. The universe doesn't hate us, it doesn't even notice us. Black holes don't hunt, gamma-ray bursts don't aim, and vacuum decay wouldn't pause for goodbye. These terrors remind us that space isn't just vast, it's alive with forces beyond our control, laws beyond our understanding, and shadows where anything or nothing might be watching. So now we turn to you. After 25 nightmares plucked from the void, which one lingers when your lights go out? Is it the silent stalkers like rogue black holes, or the sudden killers like Jabbies? The existential dread of heat death, or the uncanny precision of the red rectangle? Drop your cosmic fears in the comments. We'll face them together. And if you crave more deep space dread, hit subscribe. The universe has infinite horrors left to share, and the next one might be closer than you think.